Hello, welcome to Podsongs. I'm Jack Stafford, and I interview inspiring people in service to others as inspiration for a new song. Today I've got a special musical guest, my friend Emma Hill from Alaska. Together we're going to interview a professor of theoretical physics at the California Institute of Technology and host of the fantastic Mindscape podcast. He's also authored many books including Something Deeply Hidden, The Big Picture, The Particle at the End of the Universe, From Eternity to Here, and Space, Time and Geometry, an introduction to General Relativity. Wish us luck. Today's guest is Sean Carroll. Hello, Emma. Welcome to the show.
Yay, here I am. I'm awake. How you doing?
How is things in Alaska?
Good. I mean, it's rolling into like full-on fall weather. Real quick, how's this mic sounding? Do you need more volume, less volume?
Maybe a little more volume, yeah.
Okay, great. I'm just still learning this little guy out. I got it once the pandemic hit and I was having to live stream from my living room.
Life on Zoom, eh?
Okay. All right.
So you've been doing your research into
Sean's great. I really enjoy him. I imagine that would be a little different if I was a super religious person, but I really I don't know. I think my favorite thing so far about him is just understanding how it seems like his big goal with his love of science and all, like, and philosophy is clear, but I love the way that he's trying to make it more approachable for kind of just the common man. This idea that, we don't have to be afraid of quantum physics. And also being really honest about the idea that the quantum physics that are being used today are the same that were, that no real advancements have happened since the 50s. It's just the way that those quantum physics have been put into place to create new technology, which I think is a lot of people would not realize that. I definitely didn't until hearing him explain it.
Yeah, he's very big on the history of quantum physics. What's it called? I've made copious notes on the back of this piece of paper.
Yeah,
here.
I've got some questions.
Yeah, he's more into the, what's it called? Yeah, the development of the foundations of...
Foundations, yeah.
Yeah. So you've got some questions, yeah? I thought maybe we could tag team. So, if one of us goes first and then uses up all his time because he can be quite comprehensive answers, maybe it's better we just ask one each, kind of tag team him to beat him down. I've got an ice bucket, an ice bath outside on the balcony. I can go in between answers and lie in there. And then I've got someone else giving me a massage when I get out. So I should be ready to go after each.
Wow.
Yeah.
Wow. Yeah.
It's quite physics. No, I didn't do that well, in my last time I was studying it.
Yeah, no, me either. But it's funny how, as I think again, it's never having the right person sit down and explain it to me and help me wrap my head around, again, like you say, the very foundations of it that are the more approachable ways to just think about. First of all, it's not this, I don't know, it can seem so overwhelming, and I feel like he does such a good job of just making it more approachable, and if nothing else, reminding you it's really just we're trying to understand our current reality. And yes, there's so many unknowns that can seem really overwhelming, but the things that we do know are actually really quite approachable.
So did you get through his whole book? You got it out of the library?
No, I'm still reading it. I have it lent out from the library, but I'm enjoying it. I mostly just listen to several podcasts, and I love the one that you sent. I listened to that one all the way through, and I took some notes from that. And
yeah, he did like the Colbert Report as well and things like that. So
I need to watch that episode.
Yeah, so he's done a lot. I mean, he's great. He's given the time to speak to us, because he started his own podcast as well. So he's podcasts are everyone having their own podcast. It's fantastic.
Yeah.
It's great to meet people and I haven't chatted to you since for a long time now. Last time was when I was on tour, and you invited me over to Alaska to play in. You organized the tour for me around Alaska, which I would never otherwise do.
which was
Gosh, we
just
had
an incredible
fun.
experience. Yeah. I
That
mean,
was
I played in all,
fun.
and I only found out because I asked you about this, that you've been on this huge tour of, for your latest project, you've gone on a tour of all the national parks before they burnt down.
Yeah, that was, I spent 8 months, well, 6 months, took some time relaxing with some of Spencer's family down in Arizona. And then he stayed there with his mom, and I separated and met up with Brian, and he and I went over and did some East Coast shows. And then we actually were in Europe for all of February, primarily Germany. We worked with a company. It was a bit of an experiment, but we could not have gotten more lucky. We got out of there just in time. Like, we left on the 25th of February, and it was just starting to hit Europe of people being like, something's happening, like something's actually happening. And I feel, like very fortunate, because we have tons of friends that were starting their tours like at the end of February or first part of March, that got there and then immediately had to cancel everything and then work to try to get back over before everything got shut down.
Gosh, you played the last live concert of your career there.
We'll see. We'll see.
No, I saw you've been playing on live. I saw you playing under the water tower in Anchorage.
That was really special. That was the second in-person experience I've had since lockdown. And again, I only agreed to do that one because I knew the people organizing it were going to be safe, and everyone, there was a limited amount. They were only allowed to invite so many people, even though it was in this park. So there was probably only about 40 or 45 people, but all spread in their bubbles and all in masks, even though we were outside, which I felt I needed that, as far as if you're going to have people gathering. And yeah, it was interesting. And then luckily, the four of us that they had play, we're all kind of in each other's bubble. So that was the only reason that felt safe. I was like, well, we're already going to be doing some hanging out. So yeah, it's weird times. And the other show we did as a drive-in through a radio transmitter.
Gosh.
And that was cool, because that was I do this fundraising series for a local mental health organization here called NAMI. And I really wanted to still have one. And I was going to do it live stream. And then the guy that I partner with for that show, he was like, okay, just hear me out. I'm thinking like a drive-in show. And it was really well. It was really successful. And that was nice, just knowing everyone could stay in their cars and still have a bit of a feel for being at a show.
Yeah. Well, you know me, I'm always a pioneer. I'm always a bit ahead of the time. So even years before COVID, I was only allowing 1 or 2 people into my shows.
So smart.
Yeah.
You're so smart.
Just, I just had a feeling. So.
Oh, I missed you, Jack. It's good to hear your voice. Good to see your face.
Yeah. Life on Zoom.
I have to believe that at some point I'll be able to come back and visit you guys again.
Yeah.
Beautiful place. And I'd love for Spencer to get to see it. I'd love most of all for my parents to get to come. They just so enjoyed you both. And yeah, they're both doing really good. I'm working really hard at trying to help my dad sell his place, and he's actually taking it a bit more seriously now. So crossing my fingers that something good comes out of that. But my mom's just like really focusing on her health right now with everything going on. She's like, well, I should take advantage of just being focused. And so she's working on losing some weight and hoping to have her knee surgery next year. So hopefully she'll get her mobility a bit more up and running, which would be huge. Because I'm like, hey, I know you're 72, but like you're still a lot of traveling and a lot of world to see. So she seems encouraged. So I'm trying to help her keep on track with that.
And your music, are you recording this album about the national parks then, or?
I'm not recording it yet. I'm just doing demos, and I'm actually in the writing process. I kind of gathered, like, as I was going to each space, I was doing so much. I just mostly was writing down like lyric ideas. And then if I had little melody ideas, I was just capturing small things with the idea that I would then come and process that and turn it into a full album. So I've only written like 4 full completed songs so far. And I'm aiming for probably about 12 songs. And then I'm actually accompanying it with a book. It's going to be like a coffee table style book of my photographs and some of Spencer's photographs, if he'll let me. He's a better photographer than I am, but I actually got some pretty cool ones. And then there'll be poetry. I wrote a haiku for each park, and then and some long form poetry as well. And then several parks that we really explored and I found really inspirational. I write full essays for. So,
Gosh.
Yeah, so it's a very cool, totally out of my wheelhouse thing, but I'm having a lot of fun, and I really lucked out. I received a fellowship for it, so that's gonna basically keep us going this winter financially, and it's nice because it's just gonna provide me some time to really let myself focus just on that project because there's a lot of writing to do.
Well, I think this lockdown is very good for you. I mean, you used to tour crazy, I mean, you did, long tours all around, driving all across America, just crazy.
I know that you don't even want to hear about the one we did in Germany. That was actually the hardest. That was the hardest, most physically taxing and exhausting tour I've done. And even though it was only 24 days, but we played like 22 shows in 24 days. And driving, and the booking company that booked us, I'll never work with them again, but they did not care at all about, like, at least with me, my logistics, I always do a nice, very good, no, we were down here, up there, over there, back here. Like we just drove all across Germany and into Switzerland. I mean, we were driving like we had a 9-hour day, like in Germany, and like had to still play that night. It was nuts.
It happened to me once too in Germany. You think it looks small on the map, especially you're an American coming over to Europe. That'll be fine. You didn't type. You probably thought you lucked out getting a booker, and then you check it all. When you finally get the distances, you realize, holy shit.
Yeah, it wouldn't have been nearly as bad if I had booked it, because I just would have been a lot more particular that way. Just like I am when we're on the train. When we've done it by train, at least we're going in we're making a loop of some kind. But yeah. It was, and it's just, me and Brian are so used to having those long drive days, but it's when you're dealing with the language, all of it, you're like it's just your brain is a little extra exhausted because every time you show up, you're trying to figure out parking, and parking is very stressful. And then, trying to make sure that you're on the same page with the booker, or not the booker, but the person putting, the promoter, and just all of that. So it's like by the time you finally get to eat and then it's time to play, I was just like falling into bed every night, just desperately trying to get as much sleep as I could. It really like woke me up to being like, okay, you're not 22 anymore. And even though and it's funny because I'm living so much healthier, now in the last 3 years than I ever did.
You look in great shape, Emma, I have to say. Yeah.
Thank you. I'm just living healthier, not drinking, and all of that part is such a huge help compared to crazy me in my 20s. But I don't have the same almost like mental capacity or like patience as I used to have. It's just like I can take so much stimulation, so much problem solving and all that, and then finally I go, I need to get in bed, I need silence. I need quiet.
So you just sit back and write songs about national parks. That's midlife, Emma.
I'm loving it.
You're too young for midlife.
I love it. Well, the thing is, you have to understand, last year though, it wasn't like we took a dandy holiday. We lived in the back of our truck. We turned our truck into a camper, and we drove 30,000 miles around the U.S. over 8 months. But we visited over 30 national parks and monuments, and mountain biked and hiked, and just, it was amazing. But it was also, it was also very tiring in a different way. But that was me and Spencer, and it was such a great bonding experience, just he and I having so much time, just the two of us, and cooking over like on the back of the truck, and
in national parks, they're beautiful in America. I mean,
I mean, it was tiring in a different way, but it was so soul awakening. It was so nice to like remember like that you get to choose to like give your energy to different things, and that project was like so worthy of that energy. It wasn't about making money, it was just about experiencing as much as we could experience in a limited amount of time, and taking advantage that we both had saved up for about a year, and he was able to take off time from work, and yeah, felt incredibly fortunate. And then to have the fellowship come through, I had no idea. I was going to do the, you know me, I was going to do the project regardless. I had already done the traveling, which was the really expensive and hard part. So it was just going to be about, working, but taking the time to write. But the fellowship with the pandemic has been, well, it's been literally a lifesaver for us. We were very, very concerned about making it through the winter and what that was going to look like. And if we had to, if we were going to lose any of our rental properties and,
What about other musicians in Anchorage? Are they?
It's very hard. I've volunteered a bunch this summer working with some of my close musician friends to help them understand, like, to navigate the unemployment system, because we never, as musicians, we never qualified for that. But with the pandemic unemployment assistance that came in, we did end up having some financial relief available, but it was so difficult. So many people didn't understand. And I, just me, I'm just so bullheaded, I just sat and worked at it until I figured it out. So once I figured out the process, I worked with several people to get them through, because some people, they had nothing. They had no money. March, there was just no source of income, and it was taking months for any relief to come. And I just don't, people just don't think. For me, I also was really lucky because I did have a bit of an oh shit fund, a little bit of some savings, because I was raised to have that and to always think about that. But no, I had friends that suddenly just were really barely getting by. And so it's good though. A lot of people got together. There was a lot of gardening this year. A lot of people, I was able to, my sister's farm out in Palmer is doing amazing. And so they would send me in with a big cooler full of veggies, and I would just, give them out to people I knew were having a tough time. And there was still a lot of community even in our distance. So
yeah, that's great.
I am nervous for winter though, for a bunch of people.
Right, because also the mental health, not just the financial, but also
all of it. Yeah. So
really, you're snowed in. You could be snowed in for a long time. Yeah. Oh shit! It'll work out. It'll all work out.
It has to work out, right?
Yeah.
Or it doesn't, but we'll find out. And if it doesn't, I guess we'll really find out. So.
Thank God you've got this election coming up, and you can.
Oh God.
And we shouldn't talk about that because the podcast will probably go out after the election.
I don't want to talk about that anyway. It's too much.
Let's talk about physics. Let's talk about
that. Is exciting. This is like.
So do you have had an idea for a song yet? Because, I'm a blank here.
I think that the idea of. One of my big questions is I really want to ask him. He's dabbled in so many areas. I want to hear him say like what he feels like his like life's work, like what his main, like if he could like take everything and say like the thing that he's worked the hardest at. And I want to hear that, because I want to know if he also thinks, because so from what I've gathered so far, it really feels like it's this idea of taking his love of physics and making it approachable, making it a more common knowledge for the world, and at least getting people encouraged to look into it, encouraged to read about it, encouraged to know more. And I wonder if he feels that way, because that's just what I'm taking from it. So I want to hear about that, because I think that's a really nice idea. The idea of making something that feels inapproachable approachable, or impossible possible. This idea of taking something that seems so mystifying and turning it on its head, basically, something, along those lines of talking about that.
That's good. Yeah. And we make it rhyme, and then
we'll just have to, us, that'll come. You and I, we're an old tag team on that front. But I think it's a concept, just that as like kind of examining someone's life work, especially like, as he says, what he does and the way he talks about it, he's very humble. Like, he understands that the work he's doing, like, he's not going to win a Nobel Prize. He's not going to have huge notoriety and fame. He obviously is, as in the scientific world, is very known. And you can tell it doesn't bother him. He likes the pursuit of the the combination of the philosophy and the science, and the idea that you can, I don't know, expand the image of this form of science on the whole. And there's a bit of a sacrifice there, but I think it's really paying off. I mean, you and I, it's like people like you and I who are, lowly musicians, are interested in and reading his books and listening to his podcasts and thinking about it. I've been having conversations, just thinking about. I love the one of the quotes that I wrote down that I love. Probably my favorite quote from that podcast, the one you sent me, was, "There's not room in reality for everything to be infinite." And I liked that idea so much. The idea that, the way that the human mind has developed, we so badly want there to be this, even those of us that I get it. I still find parts of myself spiritual, and just wanting there to be, like almost needing there to be a bit of this mystery to kind of leave some of those really big and hard questions open-ended, so they're not so terrifying, because if they seem so solidly answered, they can seem very discouraging. I mean, I think that's the whole reason religion exists, is basically a big old band-aid for the level of fear that a lot of people have with not understanding the purpose of their existence, or of course what happens after. But I think it's so interesting that, like, I don't know, when he says things like that, it's like, if you really want to come to know reality, you have to let go of that part, because there is no open-ended. If you're looking at the science, the way that science understands reality, at least currently, like there is a finite way to look at the reality that we have. And there really isn't room for these open-ended. There's room for different predictions, and acknowledging that all the knowledge that we're currently working with is technically, a lot of it's just big predictions. It's not proven. It can't be proven. But this idea that there's just this, well, it could be this, or it must be this, without doing the science behind it and being like, but what is the reason for those predictions? You can't just have this infinite amount of question marks and use that as a basis for your reality.
Well, that's great. Yeah, I think we can be kind of good cop, bad cop style, because I've been on more of the metaphysical side, that there is a God. It's just not in that standard way, and that there are these other realms of manifestation, and I'm kind of a little bit contra to that. So I think it'd be quite interesting.
Yeah, I mean, and that's what's so fun, is I just like hearing about it, because it's not necessarily that I completely agree, because again, I like the idea of constantly I like the question marks. I like the idea that when you leave yourself open, but I guess for me, I like that he's reminded me to put more structure into that idea. And I don't know, for me, like expanding my knowledge enough of surrounding it, that I'm at least willing to look at the things that can be explained with the current science. And then if I want to expand further than that, it's like that idea. So I just really...
Okay, he's here. Hello, Sean.
Hello, how's it going?
It's going great. How are you doing?
Good. I'll give you my video. Here I am.
Hi, Sean.
Brilliant. So I'd like to introduce you also to Emma Hill, who's another musician.
Hi, Emma.
Hi, Sean. So nice to meet you.
Because I think to interview one physicist, the ratio is about 10 musicians to one physicist. But I can only get Emma, so she's going to have to. She's up in her game. She's read all your books, and I'm just gonna leave it to her. I'll chip in when I can. We'll do a kind of tag team questioning. So
I'm ready.
All right. Well, I don't think you need any introduction, but just to anyone that doesn't know about you, I've got your Wikipedia page here, and you're a theoretical physicist specializing in quantum mechanics, gravity, and cosmology, a research professor in the Walter Berg Institute for Theoretical Physics in the California Institute of Technology Department of Physics. I know it's a long page. You've done a lot. You've written a lot of books, appeared on more TVs and radio and podcasts than most people put together. And you're doing wonderful work. We're all big fans. So thanks for taking the time to speak to us.
Thank you. Thank you very much for having me on. It's fun.
Yeah, and we've obviously also been listening to your own podcast, Mindscape, which is fascinating as well.
It means that I have a good microphone here. I almost forgot to use it, but I remembered, oh yes, podcast. I should use the good microphone.
Okay, fantastic. Well, I'll let Emma kick things off because she has some questions ready. We'll switch. So to keep it interesting, like one of those soap operas where you have these characters discussing things in different realms of existence. So we kind of switch like that.
Okay, well, Sean, I'm very excited. I have been reading your latest book, and I'm not all the way through it, but I'm really enjoying it, and I've listened to lots of podcasts. And so in one of the podcasts, not your own, but where you were a guest, I heard you say, I wrote down, there's not room in reality for everything to be infinite. And I would just love to hear you expand on that, if you can. I was so struck by it. I was actually driving when I heard it, and I pulled over to write it down.
I'm actually, so I'm not sure when I said that or who said that or what the context is for saying that. I mean, the reality is that I'm pretty open-minded about infinity. We don't know whether the universe is infinite or not in a lot of different ways. We don't know whether it's infinite in space, whether you can go out there infinitely far. We know we can only see a finite amount of it, because when we look at the universe, we look backward in time. We're using the speed of light, right? Everything that is 1 light year away, we see it 1 year ago. And the Big Bang gets in the way. 14 billion years ago, there was the Big Bang, and you can't see past that. So there's a region past which we can't see. Maybe the universe goes on forever, and maybe it doesn't. We just don't know. We also don't know whether it's infinite in time, either to the future or the past. The past, of course, we have the Big Bang, and people often speak as if that's the beginning of everything, but we don't know. Again, the current state of theoretical physics is not enough to say whether the Big Bang was really the beginning or whether, as I like to say, it's just the end of our theoretical understanding. It's possible that there was space and time before the Big Bang, and we don't know whether the future of the universe is going to be infinite or not. Right now, our simplest models say that it is, but we don't really know for sure. And finally, we don't know whether or not there's an infinite number of things that can happen in the universe, right? No matter what the spatial size of the universe is, you can ask yourself, how many ways are there to arrange the stuff inside the universe? We don't know whether that's finite or infinite. So I'm not sure, again, the context in which I said something like that, but it's possible the universe is finite. It's also possible that things are very different.
Thanks. Okay, yeah. Wow.
That's a good one. Okay, following on from that then. So if you're not sure if the Big Bang, you know the Big Bang happened.
Yes.
Well,
let's put it this way. Something happened. We know that about 14 billion years ago, the universe was in a hot, dense, rapidly expanding, pretty smoothly distributed state. And since then, over the past 14 billion years, the universe has expanded and cooled and galaxies formed and all that stuff. That we know. So we call that whole picture the Big Bang model. It's not the Big Bang event, which was that moment 14 billion years ago when everything supposedly started. The Big Bang moment is something we don't know much about at all. But the Big Bang model of expanding and cooling from an initially hot, dense state, that we're pretty confident in.
So there could be continuous. This could be hundreds of Big Bangs before this, and they go back, and then there's an...
Could be, or an infinite number.
Yeah.
There's models of the universe. I mean, the way that we do science, right, is we look at what we have, we collect the data that we can from what's going on in the universe, and then we construct models or theories or hypotheses, whatever you want to call them. And then we ask which of them fits the data the best. When it comes to the Big Bang, there are many different models, all of which are perfectly plausible, and it's very, very plausible that the correct one hasn't been invented yet, right? So in some models, the universe had a beginning at that time. In some models, it was a bounce. There was one special moment in time when the universe had a minimum size. And in other moments, like you said, it happens over and over again in different places in space, different moments in time.
Okay. So here's the question then. If there was a time that we don't know anything about before, and we can never know anything about because it's before we know things about, Stephen Hawking said, so long as the universe had a beginning, we could suppose it had a creator. And I know that, you've written many articles about atheism, and you said there cannot possibly be a God. We don't need a God. But if there is this time we don't know, how can we be sure that some entity or consciousness didn't kick things off?
Can't ever be sure about any of these things. Being sure should not be your goal. Higher or lower levels of confidence in different possibilities should be your goal. And look, both religious believers and atheists very often fall into the pattern of knowing what the answer is and then using reasoning to get there. Okay, so it's a little bit backwards. And Stephen Hawking was no different. He did not believe in God. So he's happy to say, well, this or that cosmological model shows you why God doesn't need to exist. I'm much more relaxed about that. I don't believe in God myself either, but I think that as a matter of logic and reason, I can imagine the universe had a beginning or the universe didn't have a beginning, and I can imagine God exists or God doesn't exist, and all four possibilities in the little 2x2 table seem to me perfectly plausible a priori.
Okay.
Oh, this is exciting. I guess I'm wondering, it's a pretty scary time in the world right now, and there's so much to be. It feels like constantly every day we're just bombarded with something else to be concerned about, and I'm really curious to hear. I heard you talk about it in some of your podcasts, but what you right now, I feel so silly saying this, but what is the thing we should be fearing most right now? Like, as far as I'm not saying this just to get terrified. I'm more of like the things that if we're going to take the energy to be asking these questions, what should we be focusing as like the everyday person, or for someone like us, a musician with a platform, what should we be bringing attention to if we're going to share knowledge as far as things that are actually like real things we should be fearing and considering and working on right now?
Yeah, no, look, I think it's a very fair question. I don't think that you should worry about getting people afraid, because there are things that you should be afraid of, right? When you're in a car and you're going to hit something, not panicking people is not your goal. Not hitting something should be your goal, right? And I think there's a couple of different kinds of threats. I mean, we could do the whole podcast about threats to the universe. I've done podcasts about threats to the universe. From super intelligent artificial intelligence taking over the world to an asteroid hitting us and destroying everything. There are definitely threats out there. I think there are two big ones that are, the kinds of things where it's not just hypothetical, but it's really a worry. One is obviously climate change. The rate at which human beings are changing the biosphere and the climate of the planet we're living on is unprecedented in the history of the Earth. And maybe we'll adapt and everything will be okay, but probably not when you have, ice, permafrost sheets and glaciers that have existed for millions of years melting and changing things very dramatically. There can be runaway effects. It can be a disaster. Like, I don't think it's overblown. I think that we can do things about it. We can take actions, but the actual willpower to do that is not always in evidence among the various powers that be. The other thing that I'm very worried about is the status of democracy in the world, not just the United States, where I am, but in the world. And, look, I did a little amusing poll on Twitter a few months ago. I said to my Twitter followers, right? So like that's already a biased sample of the world, but I said, which would you prefer to be ruled by, the popular will or a wise, benevolent leader? And 2/3 are in favor of a wise, benevolent leader. And I pointed out, you're saying you would prefer a benevolent dictatorship to a democracy. And they said, well, but you phrased it so the dictatorship sounded good. and I tried to say, well, yes, that's how they will do it when it actually happens. And, I think that not only are we in a situation where there are political parties and institutions that are undermining democracy, but we've been taking for granted for so long that democracy is a good thing that people are not really deep down in their bones committed to the idea of democracy anymore. Like, you mention the word democracy and they instantly think of the problems with it, right? The shortcomings. Well, we don't really live in a democracy. The government doesn't listen to us, et cetera, et cetera. And that makes it very, very easy to give things up. We have other countries like China that are doing very well economically and don't have a democracy, and people look at that and go, well, maybe that's a better system. And I think, to me, that's enormously scary. I think that without democracy, the rest of it isn't worth it. And so, not to be a downer to your audience, but it's not a very cosmic or scientific worry, but it's, to me, the single biggest worry that I have in mind right now.
No, thank you. I was very curious because, of course, there are so many directions you could go with that, but I really appreciate that answer. Thank you.
Yes. I'm quite interested as a student of metaphysics in the way that, because I thought I had some crazy ideas. In metaphysics, there's many, many theories, and you had I was reading in your Something Deeply Hidden book, worlds theory, and that's more far out than anything I've heard from so, but just to sum it up, is that there's infinite every time you take a decision. Is that right? That there's an infinite variations. There's an opposite in another parallel universe that happens.
Well, let me sort of clarify in two different directions. One is, so what many worlds actually says, let me just say what it actually says first. It's the idea that in quantum mechanics, we have this principle that we've had since the 1920s, that you can't predict what you're going to see when you make a measurement of a quantum mechanical system. You can predict the probability of different possible outcomes, but you can't predict with certainty, okay? And no one knows exactly why, or at least people don't agree on exactly what's going on that gives us that uncertainty. But it seems to be a feature of quantum mechanics that was never true of any other theory of physics, that in principle you can't measure the state of a system exactly. So what many worlds says is that what actually happens when you measure is that every single possible outcome comes true, but in a different universe, okay? The universe branches into all of these different possibilities. And so the crucial things that I want to sort of amend to the statement that you made is, one, it has nothing to do with decisions. It has nothing to do with saying, well, will I have pizza or will I have Chinese food, okay? It has to do with measuring quantum mechanical systems. That's when the universe divides in two. It doesn't have to be a human being. It doesn't have to be, it can be just the world video camera works perfectly well for measuring quantum mechanical systems. And there's a more technical definition of when the branching happens. It's just a physical interaction. And the other is, it's not quite true, but it's closer to being true, that everything happens or an infinite number of things happen, okay? Again, we don't know whether the universe is infinite or finite, even in the space of possibilities. So many worlds is governed by an equation, the Schrödinger equation, Erwin Schrödinger, the famous physicist, put forward this equation, and many worlds is based on the idea that that equation holds true all the time. Other approaches to quantum mechanics don't have that being the case. So what that means is not that everything happens, but that things predicted by the Schrödinger equation happen. So some things will happen and some things won't. And that it might be an infinite number of things happening or a finite number of things. My favorite example, because it's crystal clear, is if you have, let's say, a proton, okay, a positively charged particle that is inside your atom. You also have electrons, negatively charged particles that are zooming around the proton. A proton will never convert into an electron anywhere in the multiverse, because that would violate conservation of electrical charge. And that is not something that is allowed by the Schrödinger equation. So it's something you can imagine, but it's not a possibility that will ever become real.
So that wasn't clear to me. Now you say that, I remember there was this app you said that you can get, which they'll split a particle for you at that moment.
That's right. So there is an app you can get if you're on iPhones. Sadly, not available for Android as far as I know. But there's an app called Universe Splitter. And what it will do is it sends a photon, a particle of light, down a beam, and then it splits, goes one way or the other. And you measure, did it go left or did it go right? And according to the rules of quantum mechanics, there's a world, a universe in which it went to the left, one in which went to the right. So it's not that if I decide to have pizza versus Chinese food, I change the world. There's not necessarily two copies in which different things happen. But if I make that decision based on the app, if I say, okay, if a photon goes to the left, I'll have pizza. If it goes to the right, I'll have Chinese food. Then there are two different worlds, because then you truly measured a quantum system and base your decision on that. So you can base your decisions on quantum mechanical measurements, but decisions don't lead to quantum mechanical measurements necessarily.
But what gave rise to this theory? Because the many worlds theory, you cannot prove it. You can't go to this other world. So is there no evidence for it?
Well, it depends on what you mean by evidence, right? It makes predictions, and so far all the predictions have come true. There are some predictions that it makes that you can't test, right? But that's true for every kind of different theory. I'll tell you how it came to be, because, in the 1920s, when we were setting up the rules of quantum mechanics, that's the royal we, I wasn't around, I didn't help. But, Schrodinger came up with his equation, and other people, Bohr and Heisenberg, and a whole bunch of people were involved in the birth of quantum mechanics. And like I said, they invented these new rules for what happened when you observe a quantum mechanical system. So unlike any other theory of physics, the rules of quantum mechanics come in two different lists. One is a list of what is happening when you don't measure the system, and the other is what happens when you measure the system. Okay, no other theory of physics is like that. And the rules for what happens when you're not measuring a system are very simple. Like those are rules we have no trouble understanding, and everyone agrees on what those are. And then it's the measurement process that becomes tricky. So in 1950s, not 1950, it was around 1957, Hugh Everett, who was a graduate student, realized for the first time that you could solve the problem of measurement in quantum mechanics just by getting rid of all those rules having to do with quantum measurement, just by taking the simple rules that everyone agreed on and saying that they are always true. There's an equation called the Schrodinger equation. It tells you how the quantum mechanical state of the universe evolves. The price you pay for that is a very clear prediction that the universe branches into multiple copies with different things going on. So it's not like people sat down and said, well, we would solve all these problems if we invented many worlds. What Everett realized is the worlds were always there, and all these extra rules about measurement basically we're erasing almost all the worlds, leaving us with one randomly selected world. And Everett says, why do we have to do that? Why don't we just let them all be? You're only going to find yourself in one. It's simpler, and it gets rid of all of this mumbo jumbo about what it means to do a measurement. Do you have to be conscious? All that stuff just goes away.
But that seems the most, solving it with the most far-fetched idea you can't argue with it. Oh, you created another world. That's just, it seems so far out there.
Well, the equation that predicts these other worlds is the same equation that we use all the time in quantum mechanics, the Schrodinger equation. So if you don't believe in the other worlds, you have to believe the Schrodinger equation is not always correct. And there are tests going on to see whether or not the Schrodinger equation is not always correct. There are explicit quantum mechanical theories, alternatives to many worlds, which make predictions that say sometimes the Schrodinger equation is not obeyed. Right. And there are tests going on right now to look for those effects, but they haven't been found yet. So far, all the evidence is in favor of the many worlds idea.
Okay, but that's like you didn't find America until discovered. But I guess that's a good thing about physics is that it's continuously, there's many counter theories. And if you find, you can hold up one person that believes this, and then someone will tell you that there's evidence for the opposite.
Well, what you do in physics is you compare different models, like we talked about with the Big Bang, right? You don't deduce ironclad, rock-solid conclusions from certain facts. You say, well, here's a whole bunch of facts. Here's a whole bunch of data that I have about the universe. I'm going to invent a lot of different theories that might potentially explain them. And then let's ask which theories are the best fit to the data, okay? So if someone has an alternative to many worlds that is well-formulated, makes predictions, the whole bit, then we'll compare them. We'll test them, right? But you can't just say, well, this theory predicts things that I don't see, therefore I don't like it. You have to give an alternative that does better.
All right, we'll put a pin in that and say there is this many worlds theory. I just wanted to give an example of that's a pretty wacky idea. And then, because in metaphysics, what I've studied is that there's the electromagnetic spectrum, and that we are solidified light at this frequency. It's a very long thing. I mean, if it was over 1,000 kilometers long of film, we could see about 2 frames. Is that something right?
I don't know the numbers. I'm not a numbers guy. I'm a big picture kind of guy.
So we exist at this vibratory level of light. But if you go to if you turn the dial and you go to other frequencies of light, there exist other worlds and other levels of existence and other people and other life.
Yeah, I mean, I would say that's a useful analogy, but it's a different physical thing. I mean, the wavelengths of light, radio waves, microwaves, infrared, X-rays, etc., still exist in our world and can be detected. But it's analogous. It's a sort of similar physical setup to the other worlds in quantum mechanics. Look, I completely agree that the implications of the many worlds idea are really very, very far away from anything that we've experienced in our everyday lives. And if you want to take a position of methodological conservatism and say, look, I want to take the smallest possible set of leaps to go from a theory of the world to what I actually see, then by all means, that's a perfectly respectable concern to have about many worlds. On the other hand, the many worlds theory is by far the simplest and most elegant formulation as a formulation of quantum mechanics. The number of ingredients, the number of equations, the number of moving parts, the number of concepts and ideas is minimal and simple and austere in many worlds. So what you're doing is you're trading that off. This is a point I make in the book. The thing about many worlds is the fundamental ideas are super duper simple, but the route from those ideas to the world we see is long and complicated. Other people favor different approaches where the underlying ideas are more complicated and baroque, and there's sort of some moving parts that don't fit together very well, but it matches on very directly in an understandable way to the world we see. So as far as which approach is going to turn out to be correct 1,000 years from now, we'll have to wait and see.
And have you had is there a theory in physics that relates to this matter being solid at different levels of light? Is that part of physics or just metaphysics?
Well, there's, I guess it depends on what you mean. There's, putting aside quantum mechanics and many worlds and so forth, there is this idea that the world is made of fields, okay? Not just the electromagnetic field that gives us photons, but the particles inside your body, the electrons and protons that we already talked about, the neutrons and so forth, the quarks. These are all vibrations in quantum mechanical fields. But they all talk to each other, right? That's why you can see light, because the electrons in your eye respond to the photons that are coming into your eye. And it's a good news. You cannot see infrared light. If you could see infrared light, you'd be in trouble because your body gives off infrared light and your eyeball itself would be glowing and you wouldn't be able to see anything at all. So it's good news that we filtered that out and can only see visible light. But it's seeable. You can buy infrared film for your camera, right? So it's not part of a different world. It's just that different parts of the world are sensitive to different facts about it.
Okay. All right. Well, I feel I'm hogging the conversation here, Emma. I could keep going, but
I could see it. I was about to say,
bash.
now, Jack, we said we were tag teaming this. Not that I'm not really enjoying the direction you're going. I also like this a little bit of bad cop you're playing here, Jack. I guess I'm so interested. There's so many directions I want to go. So to go back to my question before with this idea of, what do we have to fear most? So that's that part of it. I guess the other question is, where do you see, so they have these very real threats to our existence. And I just wonder, like, with a mind like yours and this idea that you're just like, there's always going to be the equation, there's always going to be the prediction, there's always this answer for things. Is it infuriating to you? Do you feel like we are the worst thing, that's like we are our own worst enemy? Like, what is the equation? Like, if there's any, is there hope for you? You can say there's threats, but is there hope for humans? Is there hope for us, for even though 2/3 of your followers believe that they want to have a dictatorship, as long as they're benevolent and wise? I mean,
there is hope. I think, this is an excellent question, to bookend the other question. I absolutely think that there's hope, and I'm an optimist by predilection. In fact, I try at the end of all my podcasts to end on an optimistic note, one way or the other, which is tough for some of the podcasts. There's pretty depressing messages we get across sometimes, but I don't think that we should try too hard to either be pessimistic or optimistic. We should take into account all the different possibilities. I mean, human beings were not evolved to be rational, to think clearly. Any iPhone or pocket calculator is way better at multiplying numbers together than you or I are, even though our total computational capacity is enormously greater. We use it for different purposes. We've evolved to sort of live in a complicated world where things are unpredictable, and we have to sort of not get the exact right answer in a logical way, but do well enough in circumstances that we are likely to encounter. So when we encounter circumstances that are less likely, we fall prey to all sorts of biases and heuristics and, cognitive shortcuts that we take that can get us in trouble. One of them, to go back to the threats question, one of them is that if something only happens once every 100 years or once every 1,000 years, nothing in the human body or brain is equipped to deal with that as a real threat, right? I mean, I will probably go my whole life without ever experiencing that. So why should I worry? Long scale thinking like that. We have in-group biases, right? Like we like people like us who we know. We're suspicious of other people. There's self-fulfilling prophecy kind of biases, wishful thinking kind of biases, a whole bunch of things. And yet we are able to figure out an enormous amount about how the world works and build these wonderful structures. That's the amazing thing to me, is that even though we were not, for example, evolved to do mathematics or physics, we're still pretty good at it. We could be better. We'd like to be better, but we've made enormous progress at this. And so I think that, human beings have crossed a threshold in terms of intellectual development where even though we're not perfect reasoners, we kind of know what it would mean to be perfect reasoners, and we can try to do better, right? We can try to train ourselves to be more rational. We can try to train ourselves to look at larger timescales, to overcome the evolutionary shortcomings that we got over the hundreds of thousands of years of evolution or whatever it was. And so as much as I think it's good to worry and be realistic about what we do wrong, I am optimistic that we're going to be able to figure things out. We just have to sort of continually cajole each other to try to be better and do the right thing and work together and make the world a better place.
All right. Thank you. I appreciate your optimism.
Okay, my turn. So I was thinking, if the universe is almost 14 billion years old, and that we're the cream of the crop, according to science, that we are the most evolved beings that we have yet come across. But we have evolved in Homo sapiens is about 300, hundreds of thousands of years of evolution is about 300,000 years as Homo sapiens, which is quite a blinking in eye of in terms of that scale of time. And that sounds strange that it's more logical that there's many other evolutions in this time. And this year the US Navy has released footage of aliens, UFOs, unidentified objects, and there's been many sightings of UFOs, and you probably get asked about UFOs a lot. So in metaphysics we say that they're living in different octaves of manifestation, so they're living on other planets, just at different levels of light. And so what is your opinion of this of UFOs and life on other planets?
Yeah, I think that I'm completely willing to believe that there is life on other planets, potentially intelligent life, civilizations, etc. I am extremely skeptical that UFOs have anything to do with aliens or visitors from other planets. It just seems absolutely absurd to me to imagine that a super advanced civilization is able to hop in a spaceship, travel light years across the galaxy to get to the Earth, and mostly succeed at hiding from our ability to detect them, but not always succeed, and occasionally be seen by pilots in thunderstorms or, fuzzy pictures. It just seems entirely implausible when the alternative is There are no aliens visiting us in spaceships, and sometimes people make mistakes about what they see under difficult conditions. So, in terms of being a good rational reasoner, what is the simplest, most elegant solution for this data that we have, that there are photographs or videotapes of things we can't explain? There's a million more plausible explanations that they are visitors from other planets. Again, very happy to imagine that there are life forms on other planets, but that's something else that I'm going to be humble about and say I don't know. Just like whether or not the universe is infinite, I don't know whether there is life or intelligent life on other planets. It is possible, there's lots of planets out there, right? I mean, people say, well, there's so many planets, there has to be life. That is a very, very obvious logical fallacy, right? The number of planets that have life on them equals the number of planets times the fraction of them that have life on them. We don't know the fraction of them that have life on them. It could be really, really tiny. It could be 1 in every 10 to the 100, in which case no planets in our observable universe have life on them other than Earth. It's also possible that most planets have life on them, but they never become intelligent, right? It's an interesting fact that people here on Earth have been intrigued by for a long time. In the history of Earth, life came on the scene fairly quickly after the Earth formed. It's hard to say exactly when, but simple single-celled organisms didn't take that long to evolve. But they stayed as simple single-celled organisms for billions of years. Multicellular organisms took a long time to evolve. So it might be that we go to other planets, even here in the solar system. Maybe we'll go to Europa or whatever, and find that there's little microbial single-celled organisms all over the place. And maybe we will find that we human beings are the only, or at least we creatures here on Earth, are the only multicellular organisms anywhere in the universe. That's something we have to keep an eye out for. I just think we don't know enough to say right now one way or the other.
Okay. It's also possible that because we could wipe ourselves out. We've taken 300,000 years to evolve, and we could wipe all evidence of ourselves off the planet within a couple of hours, no? So that's also something to consider, that, just because we don't have evidence doesn't mean...
Yeah, no, it's completely... There's a lot of discussion that has been out there about why we haven't already seen evidence for other intelligent civilizations. It wouldn't be that hard to find them in many scenarios. We think about the galaxy as being big. It's like tens of thousands of light years across. But the universe is billions of years old, right? Like, if you could hop in a spaceship, go 1% the speed of light, and go back and forth across the galaxy many, many times in the history of the universe. So if there were even one intelligent civilization that was really ambitious and said, let's go colonize the galaxy, it would be very easy for them to be all over the place and be very visible and unmistakable to us. But we don't see that. So maybe civilizations that do form technology end up destroying themselves. I don't think that's the most likely plan, because, if it is a situation, or the most likely solution, because if there is a situation where intelligent life arises frequently, then the chances that every one of them destroys themselves seems to be small, right? I think it's much more in my space of possible scenarios. It's easier for me to believe that intelligent life just doesn't arise than it arises all the time and then destroys itself. It's also possible it arises all the time and civilizations become sort of fat and happy and they upload themselves to the matrix and they never leave their planet. There's plenty of different things that we could imagine, but in the absence of actual information, it's hard to draw any firm conclusions.
Sure. And just in terms of probability that, every inch of our planet is habited, down from the bottom of the seas to the top of the mountains, it's probable that life exists everywhere, and that it's another theory, another possibility that we are so limited in ourselves, and we have limited ourselves, is that we are not, they are so much above us that we can't see them, and we're not on that level of existence.
It's possible. I'm not actually very convinced by the fact that life is ubiquitous here on Earth, because on the one hand, it's spread. right? Like we do think that all life on Earth has a single common ancestor. We don't have evidence that life sprung up 100 times in different ways. All life that we've ever detected here on Earth comes from the same source, and then it adapted to different environments. So that's very different than saying that it would spring up in different places. And the other thing is that even though, yes, it's certainly true that life is fairly ubiquitous here on Earth, there's no question that it's more common on some square inches of the Earth than on others, right? We seem to see that there are some environments where life flourishes more readily than others. So, as plucky as life is, it definitely seems to prefer certain kinds of environments, which maybe means that there aren't as many planets out there that are hospitable to life as we might have thought.
Okay. Thank you. Your turn, Emma.
All right. Hearing you talk about how you've expanded your subject is physics, but you've become more and more into philosophy, and all of these different parts of your work have led you kind of, you said you don't like just sitting in one spot. I guess I would love to hear what you think, out of all the many things that you're working on, is the center of your life's work. I'm just curious as to I heard you say, you're not going to be a Nobel Prize winner. Right now your idea, you're not doing on this one thing because it seems to me that you'd like, in general, quantum physics to be a more accessible knowledge and information. I would just love to hear you talk a little bit about what your main goal with your work is.
Yeah, well, it's hard because that does change over time. Most of my career as a scientist has been focusing on cosmology and gravity. Cosmology being the study of the whole universe at the whole time, the Big Bang and things like that. These days, I'm more focused on quantum mechanics, which is, very small things as opposed to very large things. But I do think that the foundations of quantum mechanics are not quite on a firm footing. We can do a better job putting them there. So, the work that I've done over the last 5 years that I think is most exciting is trying to see how space-time and gravity can emerge from quantum mechanics. There's a long-standing issue in theoretical physics that all theoretical physicists know about, that we have these two wonderful successes of 20th century physics, quantum mechanics and general relativity, Einstein's theory of gravity that says that space-time is curved and the curvature of space-time is gravity, black holes and all that fun stuff. But these two theories are incompatible with each other. General relativity is fundamentally a classical theory, not a quantum mechanical theory. So finding the right theory of quantum gravity is a big ambition. And I think that there's an angle on that problem that other people haven't really taken as seriously as they should, which is starting from quantum mechanics and trying to derive gravity rather than starting from gravity and trying to squeeze it into a quantum mechanical box. So that's what I've been doing that I'm most excited about recently. But that's a hard problem, and any one idea is probably wrong. And, so it's you don't want to put too many eggs in one basket as far as that is concerned. I'm also very interested in the origin and nature of complex systems, right? We talk about democracy. One of the wonderful things about democracy is that it's government by self-organization. It's bottom up, right? People have opinions and preferences, and they vote for representatives or they vote for actions directly. And that's a sort of weird way to organize a society if you think about it. If you just had a boss, that would be much simpler. But this is ubiquitous in physics and in nature, that we see these complex emergent behaviors in systems that are made of much smaller systems that don't individually know what they're doing, right? We see it in ants or in birds in flight or all sorts of different circumstances where individual agents are pretty simple and they get together in large groups and they end up doing very complicated things. So I'd really like to understand that better. Again, not just me who wants to understand that, but this is a big area that people are trying to delve into. And I think that, again, there's hope for real progress in that area in the near future.
Awesome. Thank you.
Yes, we have to write a song about this. I always forget. So Emma's she's focused. She's a go-getting girl. So we need to narrow down what you would like the song to be about, not just the things we're interested in. So is there a particular thing that you would like us to sing about? Or?
Oh my goodness. Like I said, yeah, I like lots of different things. I'm going to let you be a little creative here. I think that, one thing is on the optimistic side of things, as we said, human beings are not evolved to be perfectly rational, and yet we've done a lot. And so one point I'd like to make is how amazingly successful science has been. Even though there's plenty of questions we don't know the answer to, what happened at the Big Bang or whatever, there's questions we do know the answer to. Like, we know what you and I are made of, right? We know all the particles, all the atoms and the forces that interact through which those particles interact with each other. We know that. We didn't know that 100 years ago, right? Certainly not 200 years ago. And we can do things like, Einstein, when he invented his theory of relativity. So this is 1915, okay, over 100 years ago, sorry. He and others noticed very soon thereafter that there was a prediction from that theory, namely gravitational waves, right? Like that if you took a big heavy object and you move it up and down like a planet or a black hole, they didn't know about black holes, but now we know, the gravitational field vibrates. Just like if you take an electric charge and vibrate it up and down, you get electromagnetic waves. If you take a mass and vibrate it up and down, you get gravitational waves. And physicists took this prediction so seriously that they spent $1 billion building an observatory, the LIGO Observatory, and there's a Virgo Observatory in Europe, because they had a prediction that there would be the faintest tiny whisper of a detectable signal from black holes billions of light years away through their gravitational waves. And they were right, right? Like, that's amazing to me that this equation that this guy wrote down 100 years ago is the same equation that we used to make this prediction that was tested successfully by $1 billion experiment. Same thing with like the Higgs boson that we discovered at the Large Hadron Collider. Over and over again, we invent these theories, and the theories are smarter than we are. Einstein and his friends went back and forth about whether or not gravitational waves existed. We didn't realize really until the 1960s that general relativity predicts black holes. It did all along, like ever since 1915, it did predict them, but we didn't know. So the theory is smarter than we are. And now we find black holes out there in the sky all the time. So even though we human beings are not individually that smart, we have the ability to find these really, really smart things by doing science. And I think that's a tremendous lesson and makes me optimistic for what we're going to discover next.
Yeah, okay. I really love, I guess for me, I love your level of optimism, because I'm trying to imagine that if we could, I know, and Jack and I, we have very different opinions on this, I think, but I do think that I want to believe that there's hope. I want to remain optimistic. I also, for the most part, am. I can get into spaces where I get very concerned and very real threats and very real things. I guess for me, it's very frustrating that there's not at least enough basic curiosity, it seems, in our current societies to even have these conversations on a more frequent level, even if the end result is not that you convince people out of their beliefs, but just being willing to hear the other side. And I guess I'm just so curious, how do we, if we are going to write this song, it's I want to write a song that really, I think one of the things that I've found most intriguing about your work is that, even though you're obviously very, very smart and you go on these very deep levels, but it feels like one of your goals has been to make this part of science more accessible to the common person and make it feel less inapproachable. It makes it's not just this stuff over there that if you either know it or you don't,
right?
And it's something that is so clear, it's trying to understand our reality. And I know that it contradicts a lot of people's beliefs on reality. But for me, if your two greatest fears for us was the crumbling of democracy, and of course the very real issue of climate change, and how fast we are already seeing the effects of that. It's like, how do we turn on this level of curiosity to even get these conversations going to a point that I feel like if we don't as a humanity start to all get on that level, it's very discouraging that climate change, we know the numbers. You talk about numbers. We know the predictions as far as the ticking time bomb that is our planet and the way it currently exists, and the fact that we are kind of dooming ourselves. How do we get outside of that? How do we convince enough people to at least be open to hearing the conversation and the reality of that, or even if it doesn't end up being the reality, at least hearing it out?
Yeah, no, I think these are all wonderful issues and very, very important for us to be thinking about. You're right that I do place an enormous emphasis and importance on not just thinking about science and inventing new science, but communicating science to other people. And what I would like to do is communicate the way to think about science, not just a bunch of facts about science. And I think that if I were put in charge of education systems worldwide in terms of science, I would love to make it perfectly clear to students that science is not a list of facts. It's not a list of discoveries. It's not a set of things to memorize. It's a process. It's a procedure, right? It's a procedure for learning about the world based on the very, very difficult act of deciding what things you think you're pretty confident in and what you're not confident in. And you're never 100% confident, right? You never predict anything. You never have 100% belief in anything, because there could be an experiment tomorrow that could change your mind. And I think that it's easy to fall into the two sides of things where you say, well, we know everything or we know nothing. And to live in between, saying, well, we know some things pretty well, but there are other things that we're less sure of, and I'm going to constantly change my degree of belief in all these things as new evidence comes in. That's super hard to do, because, again, we human beings are just not trained to do that. It's too hard to keep confidence in our to keep incomplete confidence in our views in mind all the time. There's many different ways in which the human mind takes shortcuts, right? And one of them is when you talk about the probability of something being true, people think that there's either 0 probability, 100% probability, or 50-50. Those are the 3 allowed things. Either something's true, it's false, or we have no idea. But in the real world, sometimes there's a 5% chance for things to happen. There's a 30% chance for things to happen, or whatever. When Donald Trump won the election in 2016, people were like, well, the polls were all wrong. We don't understand anything. How do you believe all this stuff? But the good pollsters were saying, well, there's a 30% chance that he's going to win. And a 30% chance is huge. It's not small, right? And the ability to sort of think probabilistically and accept, well, I think this is probably true, but if I get new evidence, I'm going to change my mind, right? That's really, really hard to do. And I agree with you that it's really, really necessary. And so that's why on my podcast, I will try to have people. So it's an interesting thing. I will not invite people on my podcast who I think are just wrong about everything, who are just crackpots, who are just sort of bad faith actors, trying to give people a line of goods that I don't think is worthwhile. But I think there are plenty of people who I disagree with who are nevertheless smart and interesting and worth talking to, and people from whom we can learn. And those people I love having on my podcast. So a lot of people say, well, why don't you have this person on your podcast? I'm like, because that person's just a crackpot. I don't want to talk to them. But I will have this other person who I disagree with, because I think that the dialogue is important. And making that decision, making that dividing line, no one's going to do it the same way. It's all very difficult. But we got to keep trying. There's no sort of, the reason why it's difficult is because there's no resting place. It's not like, okay, whew, now we figured it out. Now we're done. Mm-hmm. It's constantly saying, well, I could be wrong. Let me look into this. Or you're just wrong. I don't want to talk to you anymore, and not treating people as enemies just because you disagree with them. All this is very, very important and very, very difficult.
I guess scientists are as guilty as anyone. They reach that stage where they they think they've ticked all the boxes now. And
well, they are. I make the joke sometimes. You would think that becoming a professional cosmologist would make you humble because you're studying the whole majesty of the universe. But in fact, given that I know some professional cosmologists, not all of them are very humble.
But you've retained humility. Let's be honest. You have.
Sometimes.
No, come on. You're lovely. I mean, you got this aura of your lovely voice. Just such a humble air about you. It's really...
Well, one of my quarantine projects has been to become a musician. I finally picked up my bass guitar and I'm taking lessons online. And believe me, it keeps me very, very humble because I have zero natural talent at this, but I do enjoy doing it. So,
and the bass is the easiest instrument, so you're really starting at there.
I do think it's actually the easiest to do adequately. Of course, it's very, very difficult to do it well, but you can just play the root note of the chord over and over again and get by. So yeah, I like that aspect of it. Yes.
Yeah. I've been playing the same 3 chords for 20 years now, so I think you'll be fine. I mean, that's great. We can get you to play bass on the song.
I don't think you want me to do that, but thank you for the offer.
Okay, well let me ask you some questions then. That back to the bad cop questions, the probing.
Yeah,
probing. So, mind and matter. There is these two things, and I'm sure you're of the opinion that matter makes mind. Consciousness is derived from matter, or that the alternative view is that consciousness creates matter.
Mm-hmm.
So there's no 50-50 on that. It's there's
a 50-50 on everything. There are people who believe every different possibilities.
Okay, all right. I guess you've heard every theory in your time.
Yeah, there's a lot of theories, right? That's right.
So because a lot of the things that quantum mechanics seems to be moving to is this consciousness, and there's this, this, and not materialism. There's this panpsychism, and there's many other isms and schisms, and and you say yourself that when you observe an atom or you can change it. You change the way by observing it and interactions, and you can change. You can change things on one end of the universe, and it changes on the other, and things like that. So, where do you stand on any of that? I mean, is that what to you is this consciousness? Can there be this universal consciousness, which obviously wouldn't call God, but universal consciousness?
Well, I do think that there's, consciousness is one of those things we don't understand. So this is a good place to be a little bit humble. But also, I would point out that, of course, we don't understand it. It's like the most complicated, subtle thing that we know about in the universe. The human brain is the most complex thing that we know about. So what expectation should we have that it should be simple and easy to understand? Quantum mechanics is not moving in the direction of including consciousness. It's exactly the opposite of that. When we invented quantum mechanics in the 1920s, there was this idea that, observing a system changes it. And when you asked what it meant to observe something, they said, don't ask that question, go away, you're bothering me. And so this opened the door for people to say, well, clearly human consciousness is somehow part of the quantum mechanical description of reality, because the act of measurement or the act of observation is part of it. But we know more now than we did then, back in the 1920s. So we've developed theories like many worlds, but there are other alternatives that are purely physical theories of quantum mechanics. And they actually have answered the question, what does it mean to do a measurement? And it has nothing to do with consciousness or the brain or the mind or anything like that. It's just when a small quantum mechanical system becomes entangled with the wider environment around it. So you can't, in the spirit of what I said before, I cannot promise you with 100% certainty that consciousness has nothing to do with quantum mechanics. What I can say with 100% certainty is that quantum mechanics does not insist on the existence of consciousness as a primary player in the game. It's something that, we have other options that are perfectly plausible, where consciousness is emergent, where consciousness is purely physical. So my whole book, The Big Picture, was exactly about how you can understand the world as we see it in these purely physical terms. So not just the world of physics and cosmology and the origin of the universe and stuff like that, but also the origin of life, what is life, consciousness, what is consciousness, and even, good and bad, right and wrong, right, morality, how does that fit in to a purely naturalistic physical worldview? And, I think that the evidence is pretty overwhelming in favor of that, mostly because the theories are just on a much firmer footing, right? Like we have equations and the people who want consciousness to be fundamental kind of have vague impressions. That doesn't mean that they're not right. Again, this is not something we understand perfectly well. One of the people who I very strongly disagree with, but had on my podcast, was Philip Goff, who is a philosopher who is one of the world's foremost advocates for what's called panpsychism. The idea that in every part of the universe, every particle, every feature of the universe has both physical properties, but also mental properties. There's a real sense, it's a vague sense, but it's a real sense to him in which an electron is a little bit conscious. And, the argument is, look, you and I are conscious, and we're just collections of electrons and protons and neutrons. So clearly, electrons, protons, and neutrons must be a little bit conscious. I don't think that argument works, but that's kind of the most naive argument in favor of that position. So people certainly do take those points of view seriously. They're debated, very rigorously among very, very smart people. But it's not my particular point of view. I think there's much easier ways to understand the world.
But aren't you, as a conscious being, isn't your consciousness much more complex than the matter that makes up you?
I don't think so. I have 85 billion neurons in my brain, and they're wired together in an incredibly complicated pattern, so much so that we're nowhere close to mapping out the pattern of connections between all the neurons in our brain. What we can do is correlate things that you and I think of as conscious thoughts with things happening in the brain, right? When people feel pain or when they're happy or whatever, we see certain parts of their brain lighting up. So clearly we haven't come anywhere close to explaining all of consciousness yet, but all of the evidence we have says that what you and I call consciousness corresponds to something happening in the brain. So my guess is that once we become better at it, we'll have a full picture of what's going on there. But of course, I could always be wrong.
Yeah, I mean, I can't quote you the papers at it, but there's quite a few neuroscientists who've done tests that they with no brain activity, people still come back with having had incredible experiences, and the evidence that brain activity is so it's cause and effect is what causes is it the consciousness lighting up the brain, or is the brain lighting up the consciousness? And there are many people who it's the opposite to what you've said. So
it's a free country.
Yeah. Because just to go on to that, so in metaphysics, mind is a very is a key thing, just as you said with panpsychism, that there's consciousness in everything, because with the atom, there is more space in everything than you have more chance if hitting an atom. If I hit my cup against my pen, the atoms or the protons and the neutrons, they're not touching. It's the mind that or the energy that contained in each. There's no actual. It's like me firing a rocket into space. I have more chance of hitting a planet. I wouldn't than hitting a neutron hitting a proton.
Yeah, no, I think
that makes sense. That was terribly phrased. I apologize. But
yeah, but I think it's not even true. I think this is a misimpression that I can blame to some extent on my fellow physicists, because they're very bad at this. But I do in my book, in Something Deeply Hidden, I do try to disabuse the myth that's out there that atoms are mostly empty space. Atoms are not mostly empty space. Atoms are taken up by the wave function of the electrons, that is the quantum mechanical description of them. And I don't need mind to predict that when a pen hits a cup or when two billiard balls hit each other, they're going to hit each other and they're going to bounce off each other. That is a very, very direct prediction of the equations that we use in quantum mechanics. So there might be evidence that the mind is important here, but objects bumping into each other and bouncing off is not among them.
Okay, that's good. I can keep going, but I should pretty give over to him.
I'm really enjoying this. I love your facial expressions, Jack. Well, that was fun to just be able to sit in my chair and hear both sides of that. Jack, tell me, where are we at with this? When do we start to write, and how is this process happening? I feel like I'm the pilot. I'm the pilot episode here.
You've only just come on, but you're taking over the show, Emma. You know. No, I mean we have to narrow it down, but yeah, I think we've certainly got enough to write a song for sure. So yeah, I'm very excited. It's a lot. I feel a lot of responsibility, though. I mean, I feel like we have to write a symphony more than a song here to cover everything we covered.
Or a series of several symphonies, I think, would be appropriate. You should go for it.
There you go. Oh, hey, you're breaking your humble rule there, but I do really like it.
You know, I'll interrupt just to say, you know, I did these series of videos over the summer called The Biggest Ideas in the Universe. I did, you know, I forget, 24 different videos. And some people on Twitter and whatever, like, that's not very humble of you to call them the biggest ideas in the universe. But I had to point out, they're not my ideas. Like, I'm just explaining them. Like, other people came up with these ideas. So the ideas are big. It's nothing to do with me. But, you know, the ideas deserve some respect.
That's why we're interviewing inspirational people, because to make great songs, you need the good source material, no?
Absolutely.
Yeah, I definitely benefit from having the coolest stuff in the universe to talk about.
Well, I also think it's so, I mean, I love this idea that you've created, Jack, because when you're talking to people that are so inspiring, because, you know, the big ideas, these are really big ideas, but I also think it's very admirable of you that you have chosen, again, I know that you have so many facets of your work, but I really appreciate that it seems that you're focused on, like you said, making these things, making the science, I guess communicating it well and making it more approachable, I think is so crucial to the expansion of it. And again, I know that like there will always be disagreements, but I think just to have these conversations, to at least listen to the argument is so crucial. And I know that there are just, unfortunately, this weird myth that so many people are feeding into of just being like, oh, that's not me, or I'm not that person, or I don't get that stuff. And it's so unfortunate because I mean, it's very clear just in this small conversation, there are so many levels of this that I will never fully comprehend at the rate that you do, but at least I'm asking questions, at least I'm thinking about the cause and effect. And I guess I'm just so curious if we can get that part into the song, Jack. I feel like that. I mean, the ideas and the concepts themselves are beautiful, but I love, for me, the idea of wanting people to ask the questions, wanting people to hear about it is what's so intriguing to me about your work. It's just.
Which one of those 24 videos is the biggest idea if you had to rank them, Sean?
Well, idea number 24 was science. So
oh my God.
That's a pretty big idea.
Oh, you're being quite general here. I thought you were being more specific.
Yeah. I mean, the ideas are very general. It's like, you know, matter and time, things like that. Those were the video. And they're very long videos, by the way. I don't necessarily advocate
I tried to watch them, but I'm sorry, I didn't get around to them.
They get pretty detailed. But just to go to Emma's point there, you know, I've said sometimes that I want to live in a world where at the end of a long day working in the office or the factory, whatever, groups of friends head down to the pub and talk about their favorite interpretation of quantum mechanics. I think that science should be something that is a little bit more part of the cultural conversation. You know, I think that a lot of people, when they're young, when they're kids, they think science is cool, but then they don't become scientists, so they stop thinking about it. And, you know, you wouldn't have that same idea about basketball. Like, you're not like, well, I used to play basketball when I was 12, but I'm not good enough to become a professional, therefore I don't follow it anymore. You can still play in pickup games. You can get very into watching other people play it. You can sort of follow it in enormous amounts of detail. I think science should be like that. I think that people should share in the process of science. I think that scientists should say what they've discovered and also say, you know, some of their tentative ideas that aren't quite there yet, but be honest about it. Like, We think this might be true. Let's see what happens, follow along. And I think that people will become much more comfortable with the idea that science is a process, that it is tentative, that we creep up on the truth, that new experiments and new discoveries can change our minds. And that's not a bug, it's a feature. That's how science works. And I think that people should, enjoy that and talk about it all the time.
And those debates are good, because it shows the differing opinions, because a lot of people, to some people, it's scientism, Oh, well, science says this, and science says I should drink this pill, and science says I should. But really, it's you have to discriminate.
Right.
Well, also, it just I feel like I just lost my train of thought. Thanks, Jack. But I don't know. I was right there, and then. All right, hang on. Let me try to come back to it, because I had it gathered and it just left.
We'll wait. It's okay.
Jack, you go on. I'm going to sit here. I had it right.
I could edit this bit out,
actually,
but
okay, sorry. No, sorry. Okay. So do you feel like there's this, so when you say that, you wish that scientists were more open about, again, not having to wait until they're able to show, this, and this leads that, it seems that my prediction is at least partially true or heading in the right direction or all these things. Do you feel like there's this like frustrating part of human nature in the way that we've gone, where we feel like we have to keep things secret so that they can, again, like it's competition, or it's this idea that, you don't want to, there's secrecy, and there's this idea that you have to be the first person, and if you're not hush hush about it, someone's going to steal your idea. Or do you think there's still a level of that that's keeping like a barrier between the common person and casually discussing what's currently happening in discoveries in science? Where does that that greed, or that that desire to be the discoverer, or the person responsible for these ideas, is that holding us back?
Yeah, no, I think there's actually a huge number of complicated, tricky issues involved in this set of questions that you've correctly asked. I mean, one is even forgetting about talking to the general public, just talking to each other. When scientists make discoveries, how do they get credit for them, right? Especially in something like what I do, where it's a theoretical thing, I can just have an idea, and there's always the worry about being scooped, right? Like I have an idea and I'm slowly working it out and writing a paper about it, and there's the danger someone else will come up with exactly the same idea. And it's happened to me. I've scooped other people, they've scooped me, this is what happens. And there's the very real, unavoidable fact that there are a lot more people who would like to be professional scientists than there are jobs for people to be professional scientists. So the competition is not just petty, it's, unavoidable. That we're going to hire some people to be professors and other people not. And so who do you hire? The ones that have made big discoveries, right? The ones that have done great work. So getting credit for the work you've done in the current system, and I don't know how you would possibly change this system, but getting credit for the work you've done is really, really important and kind of tricky. The other aspect that you touch on is sort of the spreading and disseminating your discoveries to a wider group of people. And here there's an ongoing debate within science. Should you wait until all the I's are dotted and the T's are crossed and that something is correct before you share it with the public? Or should you just let people know as soon as you have the idea and let people sort it out? Tell people, well, we're not sure about this yet, but this seems like a promising idea. In the COVID-19 era, we have, in modern science with the internet, we have an ability to write a paper and put it online right away. So before it's reviewed, refereed, published in a journal, right? Before it's vetted by anybody at all, I can put it on the internet and there's a science paper. And someone can write a news article about it, right? And that's great for communication between scientists, because you don't have to wait for the publication in a journal. If you're in a hurry, right? If you're trying to solve a pandemic and get a virus cured, you want to be able to share information as quickly as possible. But it's dangerous if people want to misuse the results. There's thousands and thousands of papers being put online, and many of them might not be right. So I don't know. I don't know what the best system there is. Certainly, an enormous amount of it would be enormously better if people were better at judging themselves, even if they were not scientists, which sources are credible, which studies are believable, how much faith to put in things. Even if you read a news story about a scientific discovery, are all the quotes in the story from the people who made the discovery or claim to make it? Or are there quotes from outsiders saying, yes, this is a good idea? Like different news outlets have different levels of credibility there. I don't think that there's any, in the modern world where information can spread so quickly and so widely, there's no substitute for people individually having the ability to judge whether information is accurate or credible or not. And so that's what we have to train everyone in the world to be able to do.
I was going to ask you what your next book is, but you probably don't want to tell me now.
Yeah, I don't want to tell you. I have a bunch of books in mind, actually. The one that I'm definitely writing is just a textbook on quantum mechanics. So it's not very exciting, but I think it will be useful for the next generation of quantum physicists.
And the next Sexy Bex bestseller, maybe that has an inspiring name we could use in the song, or I always go for that.
Yeah, no, that's still up in the air. That I'm less certain about. The quantum textbook is definitely being written, but the I'm taking time to do physics research right now rather than concentrating on writing the next bestseller.
Well, quantum textbook's easy to rhyme, so we could always use
exactly.
That.
Yeah.
Okay, well, we could keep going for all night, but I'm sure all day. Well, it is night for me now. I'm over here in Europe, but you guys are in America.
I said. Yeah, I was like, hey, Jack, it was a big deal that I woke up before 8 a.m. today.
I think we did good, I think we, defended the honor of musicians quite well here in this,
I think so.
Yeah.
Actually, can I ask you a question? As a podcaster, are you recording our audio tracks separately, or are you just recording everything in one big file?
Good question. With Zoom, you can record separate files, but it has to be on your computer. And I'm here in the south of Italy with dodgy internet. So if I do that and my internet drips, then your questions will drip. So I just record everything as one in the cloud. If you want to record separate audio, you're best asking everyone to have like GarageBand on their computer and record the file and send it to them.
I'm doing a podcast interview with someone who only uses an iPad. He doesn't have a laptop. So I'm not quite sure what best way to do that is.
Just record in the cloud, yeah.
Zoom is a possibility, yeah.
Yeah, but your podcast, I want to thank you. I want to send anyone listening to this who's looking for because it's a philosophy podcast. It's not even a quantum physics podcast.
It's a lot of things podcast. As long as it's big ideas about understanding the universe, I'm willing to talk about it.
Great. Well, as soon as I get one, I'm going to let you know, and I'll come on the show, and we can argue about it.
That sounds good.
Don't hold out for me though. Wonderful. Well, thanks again. This has been really appreciate you taking the time to help out a new podcast, an old hand like yourself, and it just goes to show you definitely have that humbleness. It's wonderful to see.
My pleasure. Thanks very much for having me on.
No problem. Well, wish us luck with the song, and if your bass playing improves, let me know.
Okay, I will definitely do that.
Thank you so much, Sean. Thank you.
Take care. Bye-bye.
Bye, Sean. Okay, Emma. Wow.
That was so fun.
That was fun.
Oh.
Yeah.
I'm going to say right now, that was amazing that you got him on.
I got lucky.
I know I'm on this podcast, but I'm interested.
Lucky.
I'm interested in hearing this podcast, even if it wasn't me.
Well, I'm interested to hear the song. So you better go away. Make a nice big fresh pot of coffee, and start on the masterpiece that covers all those things you wanted to cover. I'd be happy with just a 1 minute nursery rhyme, but you bigged it up. You made it harder than it needs to be. So.
Well, I took all kinds of notes. It can go so many different directions. But yeah, what vibe do we want it to have?
Well, it'd be nice if he uses it. If he uses it as a theme tune for his podcast, would be a nice thought I had. But because I remember there was this podcast called The Minimalists, and they had that song. That was a nice song on there. They had from another singer-songwriter. Every little thing you think that you need, Every little thing you think that you need. Every little thing that's just feeding your greed. I bet you'd be fine without it. It's a really nice song.
That.
Yeah, so if we could have a nice little tune, he could use it.
Only if it doesn't become his theme song. I think it'd be really interesting if he ends up just playing it on his podcast.
Yeah, that would be great too. Yeah, but I think big. Yeah.
So, what do you think this process should look like? How do you want to? Do you want to just sit here and go back and forth, or do you want to split off for a while? How are we going to do it?
I usually, when I'm out for a bicycle ride and some song I'll ride through a song, where the sound waves will penetrate my brain, and I'll have something come in, and then we just compare, and then we go from there. You know, bounce back some demos, and then I'll do the mixing here in Italy, and wham bam, thank you, ma'am.
All right. Well, I took lots of notes, and I guess I'll just see where it takes me. Do I need what's my deadline on this, Jack, for my first bit to you?
Well, as soon as possible. It's better when it's still fresh in your mind. You don't go too many other things, other projects. Sooner the better.
Okay.
Yeah.
Okay.
If I say 2 months, then you'll never get around to it.
Yeah,
Whenever
absolutely.
inspiration strikes, Emma.
Okay. All right. I just didn't know, I didn't know if this was like you better have this to me by the end of the week thing, or where we're at with this.
Yeah.
Okay. All right. Well, I will spend some time on this, and thanks for thinking of me. And again, so nice I love our friendship. I love that it's very easy to just, that I feel like the sign of a good friendship is just, you just pick up right where you left off. And I always feel that way with you. So thank you, Jeff.
My pleasure, Emma. Thank you for being my first musical guest on Podsongs.
All righty. Well, I will chat soon. And happy writing, happy singing, and excited to hear what you come up with.
Likewise. We've been working flat out on the song, and it's all done.
Very good. Very good. Is anything ever really all done? I don't know. I mean, it could always be more.
No, but we tried to incorporate as many aspects of the song as you could. We both wrote different parts. Emma wrote one, and we combined them into like great merging energy fields into one song. So here we go.
Quantum leaps in quantum theory, a multiversal prism threaded from the theory string, a cosmic mechanism. Many roads are encouraged, others are forbidden, while some things stay deeply hidden. Many theories, it scratches at the gloss as carousels of parallels cascade across the cosmos. Theories are proudly postulated, formulas are written, while some things stay deeply hidden. Some are all or not convinced at all by the patterns placed before them. They interrogate and authenticate to solve superposition. Many worlds is crying out, dying to be written, while some things stay deeply hidden.
Very, very nice. Beautiful.
Thank you.
Now, how is that made? Is it all electronic, or are you like strumming the guitar there?
We did in the beginning, but that kind of got covered up by layers and layers of music the producers got into it, and they really loved it, and they went about overboard.
Cool. Yeah, no, I really liked it. Yeah, I'm glad I liked it because I was thinking like, what would I say if I don't like it? I be polite, but happily I liked it.
Oh, good. Well, it was a really fun project, and it was cool. Jack being in Italy and me being in Alaska, we really did actually write two completely different initial songs. And then when we heard each other's versions, it was really exciting to kind of see which parts fit together. And we really lucked out on the melody front as far as they really actually kind of worked. And that's
right.
Normal. So yay.
It's always the danger in collaborating, right? You can respect your collaborator enormously, but you have to meet somewhere.
Yeah, it was a really fun project, and it was so nice to use the conversation we had with you for inspiration. So thank you.
I'm glad it all worked out. Yeah.
Oh, thanks. Yeah, it was really a pleasure. I was also thinking, because I was thinking about I've been listening to your Mindscape podcast, which is so great. And I was thinking of another theory. I came across another theory that you could use. Have you heard of the 7 dimensions of creation?
I have not.
Because we live in 3D, 3 dimensions, length, breadth, and height. And there's been postulated a 4th dimension, or an additional dimension. But the word dimension is measurement, and anything which can be measured is a dimension. So the 4th dimension is time, because everything exists within a time frame, and we can measure that, so it must be a dimension.
Yeah, the 4 dimensions are pretty well known. That much we all agree on, yes.
Okay. And then the 5th dimension, because everything is also in motion in multiple directions, from atoms to planets. If you examine every tiny atom, you'll find that particles are spinning around tremendous velocities. The Earth is moving through space, and so these can be measured as well. So motion is the 5th dimension.
Well, yeah. In fact, in physics, we have something called phase space, where, of course, you don't only have motion, but you have motion in 3 different directions, right? The 3 different directions of ordinary space. So phase space is 6-dimensional because you have 3 dimensions of location and 3 dimensions of velocity.
Okay. And then the 6th dimension, because the manifestation could not exist without the power which is capable of creating the tension necessary to hold the particles of matter together in a certain state, which constitutes the nucleus of subatomic and atomic structure. This power utilizes energy and is capable of opposing certain limits upon the energy of motion, and the power which imposes direction upon motion is mind.
Okay, now you've lost me, but that's a different thing. I don't know enough about that to comment.
That's going into sort of panpsychism, so everything mind.
That's right.
And then the 7th dimension is because mind by itself is an all-pervasive energy, which for the sake of simplicity you could term as a pattern of potential, and a pattern which to all intents is static until pressures are applied from outside which dictate direction to it. So mind itself is static, but you have will. Divine will imposes those conditions upon mind which bring its potential into manifestation as directed motion in a time frame of length, breadth, and height.
Okay. Yeah, I'm not familiar with this one.
Okay. I'll come on the show then. I'll explain.
Right.
Great. Well, I'll just put it out there so it's in the mind belt. And
excellent. Very, very good.
You're very inspiring to chat to. And as you can see, I've been reading up.
So this is going to be released to the world?
All of the world.
All of the world. All right. You'll let me know when that happens. I will definitely, spread the word.
Definitely. It'll be on Spotify and Deezer and iTunes Music, and we'll send you an audio file that you can use however you would like.
Okay, that's very cool. Sounds good.
Brilliant.
All right. Well, awesome. Thanks so much, guys.
Thank you, Emma. Thank you, Jack.
Our pleasure.
Be good. Have a good day.
Bye-bye. Thanks for listening. If you enjoyed the show, please rate and review it on your podcast app. Search out the song on any of the major music services. Or you can download directly from podsongs.com. Buying the song directly is the best way you can help us financially. Thanks to Maurizio Sarnicola and Massimino Vodza for working with me on the music, and Dori Verba, my researcher. And thanks to you, the listener. See you next time.